Good morning, afternoon, everyone. Today we will be discussing the SlowLoris denial of service attack. This presentation is brought to you by Kabir Barot and Krishi Patel. Let's start with a brief overview of what we will cover today. Uh, so, these are the contents of this project. It includes introduction, attack description, attack on Windows virtual machine, and then attack results. And after that, the investigation done for this attack, and at last, the mitigation measures. So, the definition of SlowLoris is a type of denial of service attack aimed at exhausting the resources of a web server by keeping many simultaneous connections open for as long as possible. This can prevent legitimate users from accessing the server.
The SlowLoris attack was first discovered by the hacker Arsenic in 2009. It targets web servers that uses HTTP keep alive connections, make the attack particularly effective against those that keep connections open for a long period. The attack involves sending partial HTTP requests to the server. These incomplete requests keep the connections open, consuming server resources and eventually leading to denial of service. By sending this request slowly, the attacker can tie up the server's resources.
So implementation. The SlowLoris maintains a pool of open connections with partial requests. It targets specific web servers, ensuring connections remain open longer than the server can handle, which results in service unavailability. So, after that, we, uh, in our experiment, after executing the SlowLoris attack, the Apache web page became uh, unreachable, indicating a successful denial of service. This was our first point of attack identification. And after that,
We observed unusual load metrics and high CPU utilization on the server. This indicates of the server struggling to handle the numerous open connections caused by the attack. We also noted significant spike in the memory usage and the network traffic, further evidence of the attack's impact. The increased memory consumption suggests that the server was handling more requests than usual. Consistent and slow loris symptoms were also identified.
to prevent and or mitigate such attacks, several measures can be taken. Increasing the maximum number of clients or using a reverse proxy and deploying a web application firewall are effective strategies. At the network level, enabling TCP SYN cookies and configuring firewalls can help block suspicious traffic.
My name is Krishi Patel, and we are going to perform this low loris attack. So here is the code for attacking the Windows machine. So we have installed a SAMP server and it's running on port 80. So you can see we can access the web page right now and it's working fine. So let's go and attack. As soon as the attack started, it started creating the sockets. After that, we will try to access the web page. It just starts and gets loading and loading. And After that, we cannot reach the site anymore. Same with the status also. Server status, we cannot reach. So as soon as I'll stop this attack, we can see now the page. So the attack is still going on and it's generating the packets. And our web server is still running, but we cannot access due to the attack. So as soon as there are access logs for the Apache server, which shows constant traffic from our Kali machine IP, which makes several requests, and this is the first log we go through to identify this SlowLoris attack from our Kali machine. And the error logs that shows server ran out of threads to serve requests as the SlowLoris attack is sending more requests which our server is unable to fulfill. And now on to the LibreMS. So here is the overview of our Windows VM. So as we can see here for this graph shows that we have an unusual spike in the CPU usage, which is approximately touches the 100%. This SlowLoris attack attempts to keep many connections to the web server open, thereby exhausting the resources and preventing legitimate connections. So this results in the server trying to handle a large number of open connections, and this was during the 30th July and 31st July, this was recorded. Similarly, we can see for the memory usage. So we can see our processor is using its 99% and our memory usage is 92%. So we can see these the sudden spikes in the memory also during the attack, and attack is still going on. So here's the spike from yesterday's attack, and for the today attack, the attack is still going on, and we can see it already consumed the memory up to 92%. So these things can give an overview of the attack that something is wrong with our Windows VM, that our resources are exhausting, and there were spikes in the device traffic also. So let's check its graph. That's it for our analysis for this attack. As we can see, there are usage of our processor and virtual memory, and what is the usage of our physical memory.